This big tank right here, that's filled with sulfur hexafluoride gas. So when that switch is opened, there's an actual connection inside that unit. The sulfur hexafluoride gas snuffs out any arcing from any residual power that's on the line.
Hey, good morning everyone. Today's video is being made specifically for the town that I live in, the community that I'm a part of and that I've always been a part of. It will be shared publicly, so for that reason I'm not going to be mentioning specific community names and street names, so bear with me on that. I should introduce myself. My name is Aaron. I've been a lineman on the east coast of Canada here for over 21 years. I am now a troubleman for my community. We have guys on call that there's a rotation at our main office for the area. I've got a bit of a unique position where I'm on call specifically for my community, everything on this side of the river. I am on call 24/7, 365. So for that reason, I might not necessarily always be 5 minutes away from my truck. I do have to carry on with a normal life. Last night, for example, I was across town having supper when the call came in. So we did get the guys that are on call out immediately. I left the restaurant, headed home, got suited up, jumped in my truck, and immediately started investigating the outage, which I believe affected around 10,000 customers. Basically, not the outskirts of our community, but directly in the downtown area. Power was out. When I come across the bridge, she was black.
Before we get into it, I do want to bring up the Utility Expo. I went for the first time in 2023 and man, I was blown away. The sheer size of this show, it's incredible. It's one of the only shows that actually lets you get hands-on demo of the equipment, tools, and the tech that can really make a difference in your day-to-day operations. The Utility Expo 2025, it's coming up fast. I'm going to be there all week, and I've got an exclusive code so that you guys can be there too. Use my code Aaron30 to save 30% off on your admissions to the largest trade show in the utility industry. Follow the link in the description, and again, use my code Aaron30. It's good through to August 22nd, and that's to save 30% off your admissions to the Utility Expo 2025. I hope to see you guys all there. Now, let's get to the video.
So I want to go over with you all, basically from start to finish, the process, what's involved, why it can take so long. So let's jump out of the truck here and go over a few things. So this substation behind me, I know anyone that's local, they're going to recognize this location. There's two major substations in our town. One of them's other end of town, hidden back in the woods a little bit. So let's start off with this. These guys here, these are transmission lines. They are 138,000 volts. These guys over here are our distribution lines, 12,470 volts. So the distribution lines are basically like the roads in town. Once you get into a town, a city, whatever, you get all your little side streets. That's what the distribution system is. The transmission system, it's our highways. These transmission lines run from city to city at extremely high voltage, carrying the power to our substations, at which point it's converted into a medium voltage and distributed throughout the town. So there was a few mentions online last night, people saying stuff like it's a massive outage, must be a real large transformer that went out. So a real large transformer would be this guy right here. It's extremely rare that a transformer of that size would blow up. It basically doesn't happen. Now, this is your standard size transformer right up here. Again, they blow up. It doesn't happen very often. When you hear that loud explosion and power goes out, all that is, that's a fuse. This guy right here, every transformer on our system has a fuse on it. Come on, focus. There we go. When that guy blows, it's extremely loud. Generally speaking, the transformer is fine. We have to find the cause of why the fuse tripped. Sometimes it involves replacing the transformer, but typically the explosion just comes from that switch. So last night's outage, this line directly over my head, it went out. Power went out. As I mentioned, I was at a restaurant eating supper. My phone started going off like crazy. So our company, we've got access to whatever we need for equipment. Sometimes it involves very large cranes, could be excavators, off-road machines, track vehicles, but we're also not the fire department. So it takes a few phone calls, a few minutes to get this stuff as needed. That being said, I did need an excavator last night. Huge thanks to the town. I called the town supervisor who had an excavator out on site to open up a trail into the woods very quickly and efficiently. So a big thanks to them. And also a huge thanks to our local fire department. I work very closely with them quite often. There's been quite a few emergency calls lately, and man, our local fire department, both full-time and volunteers, always a great help. In fact, last night, right in the thick of things, when we were running around doing some switching to try to get power back on, a fire call did come through. When that happens, we have to stand down from what we're doing. It's an emergency, and we had to respond to the fire call, which ended up not being a big deal, and we were able to get back to our tasks. So let's take a look at the map here. I'm going to try to show this in such a way that I'm not giving away too much information. So this is my location right now. That's a GPS. It's one of the major substations for my town. These lines you see here, those are all the transmission lines going from city to city, community to community. And these here, that's a terminal. It's quite a bit different from a substation that you typically see. A lot of people aren't even aware of some of these terminals. This one here out of town, it's quite a ways back in the woods, extremely large. It's a couple football field sizes. So that's where all the transmission lines intersect. These blue lines are 345,000 volts. This blue line here actually feeds this terminal, 345,000 volts, where it goes through some very large transformers and converts into 138,000 volts. So another terminal across the river here, same idea. It's all fed from 138,000 volt lines. And this line right here is what went out last night. So you can see how this line passes through, it grabs this substation where I'm sitting at, carries on through the woods going out of town. And you can also see this tiny little line here, that's the other major substation in Riverview. So when this line lost power, this whole black area, that's our community, every single customer in this community was out of power. Right here where this line takes off, there is a switch. Every time the line takes off in different directions, there's switches to isolate the line. Isolate meaning disconnect it from the main feed. So as things in our headquarters were popping off, basically, one of their first ideas, they can electronically kind of figure out where the fault is. It's not exact, but the system was showing that the fault was on this little piece of line right here. So the first thing that we tried, when the power goes out, it's on a fail-safe system, basically so that the lines don't burn down. Sometimes, let's say for example, if it was a tree that hit the lines, it will trip the power, but basically the explosion, the arc flash in the tree could allow the tree for it to clear itself, in which case the line can be closed back in. So the first thing we attempted was to re-energize the line from head office, which did not work out. Some of you may have seen a large blue flash in the sky. That wasn't a transformer blowing. That was the fault on this section of line right here. So once that happened, our first step before driving around town and trying to pick up power, which is a very slow process using other feeds, I actually took a walk in the woods to manually operate this switch. So let's take a drive across town and I'll show you guys what was involved in that. I do also want to mention this video is going to take me about 30 minutes to film, and I do work 8.5-hour days with a 30-minute unpaid lunch break, and whenever taking the time to share this information with you guys, I trade off my lunch break for this. So I will be working through my lunch break today because I know a few people will mention that. So let's take a quick drive across town, and I'll show you guys the first stop I made. So at this point, probably a good 30-45 minutes has already gone by. I'm finally in my truck and rolling. The guys across the river, they're already out. And actually my first call was to go to the terminal. 2 terminals involved in the switching. All kinds of bells and whistles, a lot of information goes off. We do have to go to those sites to get the readings, which can be obtained by the head office. But there's also some extra stuff we can do in the field. So that's usually the first visit. Once we checked all the targets and the relays to see exactly what was going on with the transmission line, and that it didn't close in the second time, that's when I headed off to that switch in the woods. Alright, so we just arrived at my next stop during this whole process. Many of you will recognize this very popular walking trail in town. And for those of you that have walked along this walking trail, you'll know that there are some transmission lines deep in the woods here. So there's actually a disconnect switch down this trail, and it's quite a long walk heading in there. Keep in mind, it's also late at night, so I did wait for a second guy to arrive on site. Everything we do is extremely procedural for my safety, for the community's safety, and so we don't damage any other further equipment, making the outage worse during the process. So one of the guys across town that was at the terminal headed over this way. We locked up our trucks. We headed down that dark and nasty trail. So we found the switch that would have been where you can see my GPS is now, and we opened that switch, isolating this piece of line. Once that piece of line was isolated, I spoke back to my dispatcher in head office, and they remotely closed in the main line, which energized that other substation that we were just at. So that restored power to pretty much exactly half our community, still leaving approximately 5,000 people out of power. So that's the first step, to restore power to those transmission lines before we do anything out on the distribution side. So at that point, we've got a few options. We can go onto the distribution system and start closing in some switches. When you're looking at the poles, driving around town, every once in a while you'll just see a whole lot of stuff up in the air. Switches, big, they look like spiral insulators thing. There's a copper blade going across. There's open switches scattered all across town. We can close those switches in, and that will pick up the feed for a small section of the town from another substation. So we have 2 options. We can start running around doing that, which is very time consuming. The engineers have to go over the loading, see how much load is on the other substation before we can just start picking random things up. The last thing we want to do is trip out that line and lose what we've already accomplished by overloading that system. It's not minus 35 out, so that process is a little easier, but again, there's a huge procedure in doing that. So the other option was walk this line, which we'll take a look at in a moment, see what the problem is, see if it's a major problem. It might be quicker, instead of going to the distribution system, to just fix the problem in the transmission line and pick that back up. Problem is, when we do pick that system back up, it starts to get difficult to pick up the whole town, because there's going to be a huge amount of current flowing through that system. So regardless, sometimes we do have to open up some isolating devices at the substation and pick up the community in smaller sections, but it's much easier to do at the substation than it is running around through town. So at this point, we do have our transmission staff called out. There's 2 different departments within our company, distribution and transmission. Myself and many of our guys are certified to work on everything in the system, both departments. However, the guys that are full-time in the transmission department are much better equipped, and they work on that stuff every day, so they're a bit more efficient. So we did call that department out. They are at our office gearing up a few trucks and basically heading out to start patrolling the line. So rather than wait for them to patrol the line, then have to go back on what they need, I started off into the woods and started patrolling with another one of the distribution guys to see if we could get ahead of the game and find the problem. Alright, so we're just at our next stop here, guys. Now, as I mentioned online with all the chatter, a lot of people ask for updates, what's going on. The reason there aren't any real specific updates is we simply don't know yet. We know that this line is out. We don't know exactly why. The computer system can give us a pretty good idea of where, but we do have to have boots on the ground to see exactly what the problem is. Also, at this point, there's a ton of phone calls being made to other crews, other departments, gearing up for anything that we could potentially need to fix this problem. So let's take a quick look at this line. This is the transmission line that was out, this guy right here. And you can see the train's not exactly very user-friendly. So I did have a couple guys at the office loading up some four-wheelers to begin patrolling the line. That does take some time. So while they're gearing things up, there's not a whole lot we can do yet. So myself and my partner took off on foot and began patrolling that transmission line. We got to this point right here where the road looked fairly accessible. That's when we called the town and they sent out an excavator and moved all those concrete blocks out of the way so we could get our truck in there. So that transmission line, 138,000 volts. That's the line that was out of power that we now have isolated. We found some significant damage on that line. I can't go into specifics as to exactly what that damage was or what caused it. Reason being for that, and the reason sometimes we also don't mention specifics with the transmission line, is our lines are used to buy and sell power within other provinces and even the United States. That runs kind of like a stock market, for lack of better words, where depending on supply and demand, those prices can change. There are some people in our province that are sitting in our head office on computer screens constantly monitoring this stuff, buying and selling power as it's needed. Other people buy power from us, we buy power from them, and there's certain information that would be considered almost like inside trading. So these people that do this job, they're not exactly aware as to what's going on out in the field, because that can impact some decisions that they make. So that's all I'm going to say about that. But our grid is tied with neighboring provinces and, as I mentioned, even the US. So if we know, for example, that a line is going down or we see a problem and all of a sudden they start buying all kinds of power from another area because they anticipate that problem, again, that could be considered inside trading. So we do have to be careful as to what we show on that. But we did find the problem, myself and my partner, down that line, and it was a big deal. It was a major fix, which I called the guys that were loading up the four-wheelers, change of plans. We've got road access, ditch the four-wheelers, get some big trucks. We can drive right to the structures, but they had to load up quite a bit of material to make the fix. And when I say big job, it was a big deal. So that's on the go now. At this point, we realize the other half of our community, they're not getting power back for probably another 6 to 8 hours until that's fixed. So for them to start working on that, not only do we have to isolate either side of that line, a huge procedure. It's extremely dangerous to work on those 138,000 volt lines. So there's a lot of procedural stuff that we have to do to isolate, make sure there's no alternate feeds that come back up through, to make sure that there's no static electricity or capacitive inductance in that line. It's a huge process. So myself and my partner decided we're going to look after setting up this process for the transmission guys. So when they get here with the material, they can go straight to work. We had a couple other crews rounded up to head into the community on the distribution system where they could start picking up customers via those normal open switches across town. So let's head to the substation and I will show you guys what we did next. All right, so we're at the other substation now, and before we go inside the substation, we'll show you guys this here. So this is an example of one of the switches out in the field. You can see there's a gap there, it's open. That is a device that we can close in. Let's say this power comes from the other substation and these customers on the left are out of power.
we can close that switch to tie the left grid to the right grid. However, you see these cables here, that's coming out of the substation. That feeds, say, 500 customers. This one feeds 500 customers. This one feeds 500 customers. So when we're closing these switches in to pick up some more customers, we can't simply just go and close the switch and pick up 1,500 customers in one shot. A lot of times we have to open all those riser switches. Here's another one here. We have to open those all up. It can be difficult to do from the ground if we don't have truck access before we even do that one step. So this stuff all takes quite a bit of time. We're gonna start doing that once we get the transmission line isolated. And again, we did have other crews gearing up to start that process. That all being said, that stuff, guys, where I am gonna post this on the local channel, a ton of people come back here and dump their trash. Please stop doing that. Even the brush and stuff, we're constantly back here cleaning this stuff up. This isn't a local dump site. I've come back here and found entire couches, TVs. That's all stuff that we got to clean up. A huge shout out to the local four-wheeler clubs and that. They've come back here, volunteered and cleaned up the area where the trails pass through quite a bit. That's a big help, so thanks guys. And please stop dumping your trash out here. There are cameras around this entire site, and I do often see who is dumping them, and yes, a few of them have been fined for illegal dumping. So yeah, just stop that, guys. But let's head inside the substation, take a closer look at the next few steps I had to do. All right guys, so in the substation now, first thing I want to show you guys, these units behind me right there, that's called a recloser. During storms or incidents, could be an animal getting into the lines of bird or something like that, that fault current, that's going to electronically shut off the whole grid. What happens is it automatically turns back on. That's why sometimes your lights go off, right back on, because those units feed, again, probably about 500 customers. Maybe the bird got on a sideline feeding one customer. The fuse at that sideline is going to blow. That unit's going to shut off. It's automatically going to turn back on and restore power to the other 499 customers without us even having to respond. So that's why sometimes your lights go off and back on. It's a normal system process to avoid massive outages. But let's take a quick walk around here. So this is one of our power transformers, 138,000 volts. There are two of them at this substation. If one transformer fails for whatever reason, we can close a tie switch and pick up the two. These lines, one feeds this guy, the other one feeds this guy. We can shut one off and use the other power transformer to feed everyone. However, in this case, it's this 138,000 volt line that went out of power, feeding both units. So before our guys can go to work on this line here, I have to operate a few switches, which would be these guys here. This is the unit that was out in the woods when I had to walk in through that trail. That massive bar right there opens up to disconnect power. Even if power shut off, it isolates that line so that it's not connected to our system. This big tank right here, that's filled with sulfur hexafluoride gas. So when that switch is opened, there's an actual connection inside that unit. The sulfur hexafluoride gas snuffs out any arcing from any residual power that's on the line. So we disconnected both of those. Now keep in mind, probably 2 hours has gone by at this point. This stuff is all happening very fast, but in a very procedural fashion. So these switches are opened electronically from inside this building right here. But where they can be opened electronically, this is the unit where there's a motor that allows for this unit to be open. We have to disconnect the motor drive from that pipe so that in the event of an electronic failing or somebody accidentally hitting the wrong button, that's not going to close that blade in and energize this line on the guys that are out in the field working. Not something that was ever going to happen, but in the event that it did, in the very small chance that it did, it could be very, very dangerous to our guys out in the line. So this procedural stuff all absolutely has to happen before any of our guys can go to work. So we do disconnect this guy, we disconnect this guy, the motor drives, and then we head off inside the building. So we're inside the building now. I'm not going to show you guys the other side of this unit because there could be some security issues with that. But you can see from the amount of wiring, there's a ton and switches and relays on the other side where we can operate a lot of this equipment. So this is where me and my partner come to next, while the guys at the office at this point, now that we found the problem, are loading up all the required material to make the repairs. Again, I could be out on the distribution system trying to pick up a few customers. However, we want to get the major problem, that we want to get that job on the go first. So we operate all those switches, which also isolates these units out in the field so that when the line comes back on, it's not going to overload the system. Another thing we have to do, our entire operations within this building are backed up through DC batteries. So there are some multiple backup AC feeds from the grid where the whole town was out. All of our backups were down. So we do have a backup with a battery bank. So what we do is we actually disconnect the batteries from this system so that when we go to return everything to normal, there's still enough power to operate all these devices. So that whole process might have taken another, I don't know, maybe 45 minutes or so. We've got that whole system isolated. We tag the system so that as crews come out into the field, they can see the tags on all the switches to know who operated the device. That device cannot be operated by anyone without first talking to the permit holder whose information is all on that tag. So the other crews start rolling in. We meet here at the substation and have what we call as a tailboard to discuss what steps I've already taken, which crews are out on the road that are going to be working on this job, and we start lining them up to begin the process of switching some feeds around in town. So once those crews arrive, I starting to get close to my maximum working hours. So according to WorkSafe regulations, we cannot work past 14 hours anymore. At this point, I'm at like 13 and a half hours in my day. So once we had the tailboard, gave the crews all the information on the steps that I've already done, they head out into the road, I head home and go to bed in my house with no power. So I'm in bed at this point, but I do know that the next steps the crews did take. So they drove out through town on all the major roads, and in communication with our dispatcher at our central office, once they came up with a plan as to which switches can handle the extra feed, they started closing switches. So it was after midnight. Some of you may have noticed your lights coming on in some parts of town. Another half hour later, another section of whatever, 200-300 customers was coming on. That was our guys driving around the field, opening switches to isolate certain areas, closing in other switches, picking up those customers. At this point, our transmission crews were also out in the woods and fixing the major problem. So as you get further out of town, I'm not going to say the street name, but basically as you're leaving town, the opposite end of town is where that first substation was. By the time the power gets there, especially picking up all the customers in between, it's no longer efficient to pick up those customers. Let's actually look at the map here. All right, so we got the map. So the first substation over here, and these customers all down here were also out. So we're using distribution lines from that first substation to pick up everyone in this part of town, and also starting to go out this way. And the system becomes, I don't want to say overloaded, because there's all kinds of room in our system for picking up this stuff, but there becomes a situation where there is a safety factor
that we can't overload our system by a certain amount of amperage and stuff. So we hit that safety factor. We don't want to cause another issue by getting too close to that. And the guys out in the field are already working. They give us a timeline, say another 2 hours, we'll have this fixed up. So the crews that are out there switching, they get on as many people as they can, and then they stand down and start responding to the dozens of calls that come in throughout this entire process. When power goes out to the entire town like that, a lot of phone calls come in, especially when people see the blue flashes in the sky saying, usually they say they saw a transformer blew up. We have to investigate that. A lot of those calls are duds. Crews show up, talk to the customer, they see a blue flash in the sky. That was from that initial call. In fact, that's what the 911 call was that came in. So our crews now start picking up all the smaller calls around town. The transmission crews are out in the woods fixing that. Once that is done, they have to go through the entire process of undoing what I initially did. All those switches where the motors were decoupled, walk out into the woods, close that line back in. All those reclosers, they got to start closing those back in one at a time, and then also returning to normal the switches that were all closed and opened around town, which can take hours. So I would have much rather film this as I was doing everything last night, because things were pretty intense. We were, again, very, very procedurally, but we were going around pretty quick. A lot of people at our company, including myself, I care about the community a lot. When power's out, I'm doing everything in my power to restore power as quickly as possible to you all. I appreciate online, I get lots of help from viewers that do see things and help guide me in the right direction. Appreciate that very much. I hope this answers some of your guys' questions. I do have a lot of videos online where I do film basically live what's going on, and I do include the permit and radio procedures and that to show how time consuming that can be. That's something that's worldwide. Any power company in the world follows these same procedures. It all has to do with safety for you, the community, and for our guys. So appreciate all your patience, and I really enjoy working for you all in the community. Be safe, guys.